So I'm doing my video on sodium balancing the equation of sodium phosphate plus calcium chloride yields calcium phosphate and sodium chloride, which translates to sodium phosphate, so NaPO4, plus calcium chloride, which is CaCl, when it yields calcium phosphate. So it's CaPO4 and sodium chloride, which is NaCl. And these equations, sodium, which is Na, has a charge of +1, and phosphate has a charge of -3. Calcium has a charge of +2, and chlorine has a charge of -1. So in order to balance this equation, what you need to do is you need to find the least common denominator of each of the compounds in the first half of the equation, and then you can proceed from there. In order to balance the equation, you need to equal the charges for all of the different compounds, the four that we have, and we're gonna start by balancing the first half. So in order to balance them, these two need to equal 0. So in order to do that, you need to find the least common multiple, and in this case, since Na is 1, the least common multiple will be the other one. So the least common multiple is 3. So you need to put a subscript of 3 in Na in order to balance that one. And the same thing goes for over here. You need to give it a subscript of the other one because it's a charge of -1. So it would equal CaCl2 and NaPO4. So in order to complete the balancing of the equation, you need to look at the second half of the equation, which is calcium phosphate plus sodium chloride. And you can already tell that sodium chloride is balanced because when you add the two charges together, they equal 0. But calcium phosphate isn't, so you just only need to work on that. And in order to balance it, you need to find the least common multiple again. And in this case, it's 6 because 2 times 3 is 6. So you're gonna make calcium equal to a total of 6. So 2 times 3 is 6. And you're gonna make phosphate equal 6 because 3 times 2 is 6. And you need to put that in the beginning as well. So you need to make calcium have a total of 3 in the beginning, because this is already balanced, so you don't need to put a subscript there. So you just three total of calcium, and then you do the same thing with sodium phosphate, because sodium phosphate is already balanced because it's 3 times 1 plus -3 equals 0. So you just add 2 of those rather than changing the subscript in order to get the right amount that you need in the second half. And because you changed the sodium and the calcium, or the sodium and the chlorine, you need to change it in the second half too. But you want to add it to the beginning as well, because this is already balanced. So the chlorine has a charge of 2 times 3, so it has a charge of -6, and the sodium has a charge of 3 times 2, and it's positive, so it has the charge of +6, and so they're both 6 total. So you just add a 6 there to make a total 6. So this is the balanced equation that we were just working on, and in order to just confirm that it's balanced, you can make sure that each element is present the same number of times in both halves of the equation. So you can find 3 times 2 sodium is 6, and then in the second half it's 6 sodium. 2 times 4 phosphate is 8, and it's 2 times 4 phosphate is 8 in the second half. 3 calcium and 3 calcium again, and then 2 times 3 chlorine, which is 6, and 6 chlorine. So this equation is balanced. And this equation is double displacement because you can tell that the Na is with the phosphate in the first one, and then it's with the calcium. So it's these two go there and these two go there. So they basically they switch, which makes it double displacement.